Hi, Kipsters. Today we're going to be doing Module 4, Lesson 16, the computation of a slope of a non-vertical line. Take a second to scan over our objectives for today. So we're going to be using similar triangles like we use in Module 2 and Module 3 to explain why the slope M is the same distance between any two distinct points on a non-vertical line on a coordinate plane. And you're going to use the slope formula, which we're going to learn in a few examples, to compute the slope of a non-vertical line. Find example number 1. Go ahead and plot points P and R like I've done. So let's use what we've learned in the last lesson to determine the slope of the line with the following graph. What directions do I need to move to go from point P to point R? Yeah, I want to move up 3 and to the right 1. Remember in the previous lesson, I wrote my up or down in my numerator, and I wrote my left or right in my denominator because we want to express our directions as a ratio. If I can simplify that number any, I'm going to simplify that number. I know that 3 divided by 1 simplifies to 3. Therefore, my slope is 3. All right, let's take a look at example number 2. In example number 2, don't worry about any of this. Example number 2, use what you've learned in the last lesson to determine the slope of the line with the following graph. What would my slope look like to move from point P to point R? Yeah, so I'm going to need to move up 4, and I'm going to need to move right 2. Slope would then look like M equals 4 over 2, which simplifies to M equaling 2. Let's go ahead and turn the page. So we got another example, example number 3. Go ahead and make sure you found points P and R on the graph. Determine the slope of a line with this graph. Yeah, I'm going to need to move up 2, and I'm going to need to move to the right 3. How would I express that to show my slope? So I'm going to put my up or down over my left or right, and I'm going to have that slope is equal to 2 over 3. What's different about this line compared to what's different about the slope of this line compared to the last 2 examples? So I'll go ahead and list them out for you here. So the slope in the last 2 examples, slope was a whole number, but in example 3, our slope is a fraction. This brings us to one of our key points of the lesson. That slope is not always going to be a whole number. Sometimes the distance between 2 points will be a fractional value. Let's do some more work. Let's investigate a little more concretely. So we want to see if we can find the slope between any 2 points on a graph. Let's start with point A. Select any 2 points on the line and label them as P and R. What point did you pick for P? I've labeled P. What point did you pick for R? I've labeled my P and my R. If you struggle labeling your P and your R, make sure your paper looks like mine. Let's go to part B. Identify the coordinates of P and R. What's your coordinate for point P? My point P is located at an x of -4 and a y of -3. Notice I started at my origin and I moved left to right, and then I moved up or down. Point R is located at -2, +1. Part C says find the slope of the line using as many different points as you can. Identify your points and show your work below. Well, this is where our slope formula comes into play. So remember, slope is, we're going to take some notes at the top of our paper, slope is the distance between 2 points on a line. Specifically, we've been calling these points point P and point R. So for purposes of this formula, I'm going to model using variables P and variables R. Slope is our up or down over our left or our right. If I had to transfer that over into our axes, okay, slope is going to be my y-axis over my left axis. Well, Mrs. Matthews, why did you switch over to the variables y and x? I'm glad you asked, Kipters. I've switched over to the variables y and x because I'm about to break slope down into these ordered pairs. Slope is a ratio that measures the distance between the y of point P minus the y of point R over the x of point P minus the x of point R. So again, if I go down to part B and I labeled these x and y, all right, I'll be able to then find the slope using the formula. So let's use points P and R to find the slope. So remember, whenever we're using any formula, the first step is to write down the formula we've been given. So slope is P2 minus R2 over P1 minus R1. Then I want to substitute what I've been given because I've labeled P2. Going to be negative 3 minus R2. Sorry, R2, I pointed to the wrong thing. Minus 1 over P1, negative 4, minus R1, negative 2. Notice in my denominator, when I wrote minus negative 2, I used the grouping symbol of parentheses so it doesn't look like plus plus. So I'm going to continue working vertically so you can see my math. My numerator reduces to what number when I do that math? Negative 3 minus 1. Yeah, when I get my calculator and I do negative 3 minus 1, get a bigger negative. I have negative 4. My denominator reduces to what number? When I get my calculator and using parentheses to group things, I have negative 4 minus negative 2. No, with a smaller negative, negative 2. Okay, but I'm not done. Okay, so I see two negatives being divided. That automatically lets me know I'm going to end up with a positive answer. So I'm going to say negative 4 divided by 2. M is equal to what number? Type your answer into the box below. Yeah, M is equal to a positive 2. Let's verify that we agree with our slope of being a positive 2. When we're speaking about slope, key point number 1 spoke to using similar triangles. When we're talking about the directions that we need to move up or down and the directions that we need to move left or right. Okay, when we actually plot those lines or draw those lines on a coordinate plane, we create these triangles, okay? I should be able to create the same size and type of triangle to move to the next point on the line. If I am moving up, how many did I move up to get to point R from P? 1, 2, 3, 4. Then from point R to get to the next point, and we'll say the next point is point Q, I need to move up 1, 2, 3, 4. So I'm going to draw that line. Need to move up 4. How many did I move to the right to get to point R? Yeah, I moved 2. So I'm going to need to move 2 to the right to get to point Q. Point Q is located where? Yeah, I'm going to write that down for point in B. Point Q is located at 0 and positive 5. Well, let's use either point P and point R and point Q to verify, to prove that our slope is 2. What 2 points are you picking? I'm going to pick point R and Q just because they're easier to see and they're right by each other. So I've labeled R1 and R2. I'm going to label Q1 and Q2. My formula using the variables R and Q for slope looks like what? Yeah, my formula should look like R2 minus Q2 over R1 minus Q1. Go ahead and substitute what you've been given and simplify slope. Sorry, my pen was going to think I need to scratch some places. All right, so I'm going to plug in 1 minus R2 minus Q2, 1 minus 5 over R1 negative 2 minus Q1, 0. All right, my numerator, working vertically, looks like what number? 1 minus 5, negative 4. Denominator looks like what number? Negative 2. I know two negatives divided by each other give me a positive, so I have also proven that slope equals to with that line. Examining these similar triangles, you should see that the corresponding sides, so my base measures 2 in both triangles, and my height measures 4. All right, I know if I put those similar triangles as a ratio, base to height compared to base to height, my ratios check out. I have similar triangles. Go ahead and find your exercises. Let's go ahead and find the exercises.